this is a JK flip-flop. Here the connections are, and this part is already, we know that this part is called as RS latch, and to it, so we have added this NAND gate and this NAND gate. The NAND gates of the inputs are one is J and another is K. That's why it is called a JK flip-flop. And another input is clock. Same clock is connected to the two NAND gates. And for the input of this upper NAND gate is coming from the cross coupling. That means cross feedback of QN bar is connected, and similarly this QN is connected to the another input of the NAND gate. This is how the connections is met. Then let us check what is the equations of this JK flip-flop. So here we don't know the conditions of the QN. That means we don't know the conditions of the QN. So let it be, it's a QN bar. For example, QN bar. This is a QN bar. So QN, and this is a QN bar. Okay. So coming to this QN, first inputs are J0, K0. That means 0 and K0, like this. Next, when this is the QN bar is connected to this, and the clock is always 1. The clock is 1 only when the clock is 1 and the inputs are propagated to this. Otherwise, it won't propagate it. So clock is 1, always high. That means here the output of the NAND gate is, top NAND gate is clock 1. Next, J dot is 0, and this is QN bar is connected. QN bar is connected. That means whole NAND gate. This is NAND gate output. Then what is that? Since it is a 0 multiplication of anything is called 0. That means this becomes 0 whole bar. That makes this becomes 1. So this output is of the NAND gate is 1. And similarly, this is QN, and this output is QN dot 0, K is 0 and clock is 1. Similarly, this is also 0. That means 1 bar. That means this is 1. 0 bar means 1. So hence from this example, so 1 is here and this is QN bar. Then what is the output of here? That means this output. This is the QN bar is connected to this. That means here 1 is connected. Then what is the output? That means 1 dot QN bar, because NAND gate QN bar. That means this is 1 dot, this is actually NAND gate product. That means 1 dot QN bar. So that means this becomes QN bar whole bar. That becomes QN. So this is what is called as, the equation is nothing but, so QN plus 1. QN plus 1 is equals to, that means next state, already present state is QN plus 1 is equals to the QN bar plus 1. That means 1 dot QN bar whole bar. That means QN bar whole bar. That means QN. So that means if it is present state is QN and QN plus 1 is also QN, same state. That means it is called as a memory state. Same state. That means memory state. So once again I am explaining, this is a QN bar and this is a Q bar. So this is 0 means anything 0, anything when 0 means, that means always 1. Similarly, this is 0 means always 1. So from this is QN bar and 1. That means QN plus 1. Already inputs are transferred into this. That means QN plus 1 is equation is equals to, so QN 1 dot QN bar whole bar. That means 1 dot QN bar means QN bar whole bar. That means QN. So QN. So that means that's what is called as same state, memory state. M state means memory state. Memory condition. Next, coming to the next. If it is next is j is equals to 0, k equals to 1. Then let us check what will happen. So this is okay. Then 0 1 as placed as, because 0 1, then we will go for it. This is qn bar is going to this. So this is 0 means definitely the output should be equal to 1. That means NAND gate is equals to 0 dot clock dot and qn bar whole bar. This is the output of the. So 0 means definitely entire becomes 0. That means 0 bar 1. So this becomes 1. Similarly, coming to this is qn bar and this is 1. 1 1 1 qn bar. That means 1 1 qn. This is qn. This qn is connected. That qn whole bar. That means this is equals to qn, then whole bar, qn bar. This is qn bar, right? And then we will next check for this thing. Then what will happen to this? This is qn bar is connected to going this, the 1 dot qn. So that means qn plus 1 next state. Now here the qn plus 1 calculation is equals to 1 dot, this is qn bar is going qn bar whole bar, because NAND gate. That means this becomes qn bar, this becomes qn bar, qn bar and similar qn bar whole bar. That means qn and let us check for this. That means let us check for that. Keep it aside. This is qn, then this is qn bar and this is qn. Let us check for qn. This is qn plus 1 and this is qn plus 1 whole bar. That means the next state of this is complement, definitely qn plus 1 whole bar. That means qn plus 1 whole bar. What is this? Qn bar and qn whole bar. qn bar whole bar. This is equals to, what is this? This value is equal to 0 bar. That means 1. That means this value is always be 1. When the conditions of 0 1, this value is always be 1. That means qn bar always be 1. So substitute qn bar. Qn bar 1 means, what is the qn? 0. So qn bar always be 1. Here from this calculation, qn bar whole bar is equal to 0 bar. That means 1 here. So this value is always 1. That means the complementary stage of next state is always be 1. That means qn bar is equals to 1. Then what is qn? This is arrived at qn. Then what is qn? Qn bar is equals to 1. Then qn should be equals to 0. That means this is always be 0. That means if it is a present state, qn, this is equals to 0. That means reset state. That means reset condition. That means that should be derived from this next state. Next, coming to the 1 0. That means this is 1 and this is 0. So this is 0 means definitely this equals to 1, and this is 1 means, so what is coming here? Qn bar is coming here. That means qn bar, the output of this NAND gate is, this output of NAND gate is always 1 because it is 0. And coming to this is 1 dot clock is 1 and qn bar is coming. Then whole bar. That means this is qn bar whole bar. That means qn. So here we arrived qn. Then coming to this, let us check for this. Then here this equals to this qn bar. So this is 1, and what is this? Qn is here. then 1 plus, that means first let us calculate the complementary function of qn plus 1. Qn plus 1 whole bar is equals to 1 plus qn, 1 plus qn whole bar. That means what is this? 1 plus qn is qn. That means qn is there and qn bar. 1 plus 1 is qn and qn bar. That means this is equal to qn. Then what is the value of this is? This is equal to qn. That means this is qn bar. And coming to this is qn bar plus qn bar plus qn bar. This is qn bar, and coming to this qn n plus 1 state, qn plus 1 state, qn bar whole bar, right? This is qn bar and qn whole bar. Then this is the qn state, the present state. Next state of this state. That means what is this? This is 0. Qn bar 0, whose becomes 1. That means even though this value is equals to qn or something else, qn, this always be 1. That means this is called as set state. This is also, once again I am repeating. So here this is qn because it is 1.1.1 qn. This is 0 means because 1 0 0 means always be 1. So coming to this, they are entering into the NAND gate. Then we supposed to calculate next state of this state, this output. That means qn plus 1 whole is qn plus 1 is equals to qn dot qn bar whole bar. qn bar is equals to 0 always. Already as per the formulas, a dot a bar is equal to 0. So qn dot qn bar is equal to 0. That means 0 bar. That means 1. So it's always be 1. So 1 set state. Next, coming to the fourth state, when these two are 1 1. This is 1 and this is 1. So let us check. And this qn bar is going and we are calculating for this output. That means 1 dot, clock is always 1 dot, and qn bar is coming, qn bar whole bar. That means this is 1.1 qn bar. So qn bar whole bar, that means qn is this output. So qn. Next, coming to the output of this is 1.1 and this is qn is coming. That means 1.1 dot qn is coming and whole bar NAND bed. That means this is qn bar. That means this is qn bar. And next we supposed to calculate the next state of this and similarly next state of this. And what is qn plus 1? Qn plus 1 is qn plus qn bar. That means qn bar whole bar, right? Next, what is qn plus 1 state, 1 plus whole bar state? That means next state of this complementary state. That is also qn bar, and this is qn bar and this is qn. Same qn and qn bar whole bar. So now this is the main important task. From this we can resolve how this RS latch is being toggled here. That means in the case of RS, when these two are 1 1 both, when these two are equations are, when two inputs 1 1, then automatically this is arrived at 0 and this is arrived at 0, or this is 1 and this is 1. But same things, suppose if this state is 1 and this state is 1, it's practically it is impossible because it's opposite to the principles. So similarly here qn plus 1 state is qn bar, and similarly this qn plus 1 whole bar is also qn bar, but the same thing is arrived in the case of RS latch or RS flip flop. But we can consider from this, either from this or from this. Since we are calculating this state means, so we have to modify this from, we are coming, we supposed to come from here. Then what is this? This is equals to qn bar. What is this value? What is this value? Is equals to 0 whole bar. That means if that means this 0 whole bar is equals to 1. So if it is equals to 1, that means qn bar is equals to 1. Then what should be the value? That means if it is 1 means, then 1 dot, this is 1 dot q, that means qn bar is 1. So from this qn 1 dot whole bar, then what is the value? Qn bar. That means complement of that. This is complement of that. That means this is what is called as a toggling mode. This is what is called toggling mode. Toggling mode is inverse of that. If it is present state is qn, then the next, then the, so sorry, this is, if the present state is qn, then what is the next state? Qn bar. Complement of that. If the present state is qn bar, and the next state is equal to qn, that value is complement of that. But once again I am repeating. So qn plus, from this qn plus 1 is also qn dot qn bar whole bar. Similarly qn plus 1 whole bar, complementary state of the next state is qn same, but from this we can resolve it. How it resolve means, first we need to calculate this, means we should arrive from this next state of this qn bar, this becomes 0 whole bar, that means 1. So when it is 1, then 1 is going here, 1 dot qn whole bar, like this, substitute 1 dot, that means it becomes qn bar, complement of that. So this is how this JK flip-flop is resolved. The problem of RS latch or RS flip-flop is in invalid state of when the both inputs are 1 1, then it is invalid state. This is 1 and this is 1. But this is how we can evaluated the problem of the RS latch is as a toggling. Toggling means is a toggle. T means toggle mode. Toggle mode means if the input present state is qn, next state is qn bar. If the present state is qn bar, next state is 1 qn. That means if it is 0, next state turns into 1. If it is 1, next state turns into 0. This is how the JK flip-flop is resolved the problem of RS latch or RS flip-flop.